I would call the general challenge home automation. So this is where we see more and more functionalities in a house are being, computerized, personalized. Heating is definitely one of the things that's of great importance. And what we see sort of a possibility of applying our disruptive technique to actually come up with solutions which are far more optimal and user-friendly than what we have seen before.
We are making IoT solutions where we help our customers to connect their devices to the internet. We have worked in the casting project on a floor heating system which optimizes the energy consumption. When working with the floor heating, we met a lot of challenges. This led us to the idea to talk to Aalborg University because they are really strong in the theory of how to control things and how to simulate things. So we had a good separation of concerns. They could work on the algorithms, we worked on the interfacing, and like that we were able to construct a whole solution.
We have both the controller for the actual floor heating system. If we look at it in an energy-saving way for floor heating systems, since we can control the temperature better both for comfort and for saving energy. And the other aspect is on the software side and the architecture side of how do you build this type of system. We're not building a single system for a single house. We're building a large-scale system for a lot of houses and potentially other heating systems or other energy systems.
Before the project, we didn't even know what could be achieved, and now we know this is in the near future. What we need to do is now industrialize this product. We need to make it cheaper, we need to make a generic solution which doesn't only work for my house but works for every house.
What we envisage is actually that the usage of a house can be learned from monitoring the usage of different rooms. And we would also, of course, like to take external factors into account, like weather prediction. And given these informations, we will be able to actually synthesize automatically adequate control programs.
So the weather has a very large impact on the temperature within houses, in particular the sunlight. If our control algorithm can see that we're going to get sunlight or we're going to get high temperatures, then it doesn't have to heat up the room. And then the system can save energy by using the energy at the right time and at the right levels. So this will especially be relevant in the future. We will have varying energy prices for energy at different times.
Because Aalborg University had this model of the house, and because they could take weather forecast in, and they had measurements from every room and from the outside temperature, they were able to predict more the energy usage, and that further optimizes the energy consumption of the house.
There are all kinds of room for using this technique for synthesizing controllers, maybe not central controllers, but also distributed controllers that will actually optimize the usage of scarce resources. So there is a huge potential.